Hey everyone, my name is David D. Hilster. I work in the HPC Systems architecture group. I work in the area of natural language processing, and I'm very excited and honored to introduce to you a group of brilliant students, all who have been programming in a brand new way. Instead of thinking like computers to write a program, they have been thinking about how we humans read text and then encoding it in a brand new language called NLP++. They are writing some of the first intelligent programs, and some of them are making history with their intern projects. From processing resumes, to reading tweets to discover human emotions, to creating the most comprehensive English dictionary for NLP, and a dictionary for the Indian language Tamil. And all of them using the new NLP++ plugin for HPC systems. The common response from these students has been that without NLP++, these tasks are virtually impossible. Coupled with the power of HPC systems' ability to quickly process large amounts of text, the students have told me they have found creating human digital readers using NLP++ to be some of the most enjoyable programming they have ever done. But don't take my word for it. Let's hear from the students themselves. They have come from 3 different continents and range from high school students to graduates at the university level. The first to speak is Charvi Dave. After she completed her internship as a student through LexisNexis in India, she was hired and is now a full-time employee of LexisNexis. Congratulations, Charvi. Charvi worked on the first part of a digital human reader for resumes. Charvi, take it away.
Thank you, David. Good morning, everyone. My name is Charvi Dave, and this is my HPCC Systems internship project, the Resume Analyzer in NLP++. Coming to our problem definition, why do we need a resume analyzer? In major industries, in companies all over the world, the HR team often find themselves stuck in tough situations. They find themselves thinking how they can go through the thousands of the resumes that are being sent to them daily, all of these resumes being in different formats. They wish if there were an easier way to view and analyze these resumes, how they could really fetch the profiles with the correct combination of the skills, languages, experience, and expertise that they require. In response to this problem definition, we have proposed a solution, that is the resume analyzer in NLP++. What is a resume analyzer? It is something which takes the resume as an input, goes through the resume, identifies and classifies sections of the resume, namely the person's name, skills, email ID, work experience, certifications, projects, etc. It extracts this information and stores it in text files and a knowledge base. Coming to the features of our analyzer. The main intent of our analyzer is to extract key information from resumes about job applicants in the most efficient manner possible. Accurate extraction. Our analyzer extracts the main sections and headers of the resume with pinpoint accuracy without compromising performance. Flexible design architecture. Our analyzer is made up of multiple passes of code. Each pass of code performs a different task, that is, it extracts a different piece of information. So these passes of code can easily be edited and modified as per your needs. You can add or also delete passes of code. Hence, it is customizable and adaptable for new users based on their needs. NLP++. We have built this analyzer in the programming language NLP++, which is a powerful programming language for natural language. It consists of multiple built-in English dictionaries and tokenizers, and we can also create dictionaries of our own. Its output files consist of default log files and also a final syntactic tree. Knowledge base. Now, knowledge base is a very important and unique feature which is only present in NLP++. A knowledge base is kind of like the brain or like the memory of the NLP++ analyzer. The knowledge base essentially stores all of the information from the resume in an informative and concise form. It is easier to view and analyze the knowledge base more than it is to view and analyze the actual resume. Coming to the workflow. Currently, NLP++ can only take text files as an input. Hence, throughout this project, the Word, image, and PDF resumes that we've worked with, we've converted them to text files using Python, and we've taken that converted text file of the resume as an input in NLP++. Then the analyzer was run on that particular text file. So the analyzer passed through the resume, extracted the sections and pieces of information, and stored that pieces of information in text files and knowledge base that we have defined. This is just a quick snapshot. So I'm just going to give a quick overview of the NLP++ environment. NLP++ is present as an extension in Visual Studio Code. As you can see here, this pr12.txt is the converted text file of the resume. Over here are all of the text files that we have uploaded onto NLP++. Analyzer sequence, so this refers to our analyzer, and these are all of the passes of code. The first pass is the dictionary tokenizer, which is present by default. The second pass of code extracts the person's email ID. The third pass of code extracts the person's phone number, and so on. So when we click on this run button next to the text file, it essentially runs the analyzer. That is, it runs all of the passes of code on that particular text file. And it gives us these output files as present below, the final syntactic tree, log files, and the text and knowledge base files that we have defined. KB here stands for the knowledge base. So this area consists of the knowledge bases and the dictionaries that we have created. And here are all of the analyzers that we have created. Resume format or zoning. So essentially what we are attempting to do through this solution is we are attempting to extract the main pieces of information from the resume and also the main sections from the resume. For example, in pieces of information, it could mean the person's mobile number, it could mean the person's email ID, their LinkedIn account, and so on. And also sections such as the profile summary, the work experience, the person's education, and so on. So after we run the analyzer on the particular text file, these are the main files that we get as an output. First is the resume output.txt file. So this consists of the miscellaneous pieces of information, such as the person's email ID, their phone number, their LinkedIn account. Next up is resume sections.txt, which is essentially the sections of the resume. The first section here, or the first zone here, is the personal information zone, which consists of the person's name, their email ID, their phone number, their address. So that is the first zone, which is followed by the work experience zone, the education zone, skill zone, and so on. Now coming to the most important part is the resume.kbb file, which is the knowledge base file. As I mentioned earlier, it is a more informative, concise, and compact way of viewing the actual resume. So instead of viewing the resume as it was in the previously shown PDF form, this is how we view it in a more concise and compact way, with only the main pieces of information visible, such as the person's name, their skills, their languages, tools, environment and certifications, and so on. Concluding, I would like to say is through this solution, we are attempting to automate and simplify the recruitment process, and the time and effort taken for identifying the right talent and shortlisting the relevant resumes is reduced. We have used NLP++, which is a powerful tool to use to work on natural language. And this project can and has been further extended. Thank you.
Okay, well, thank you very much, Charvi. That was really great. And congratulations on becoming a full-time employee at LexisNexis. Next up is Kruthika, who is a student at RVSE University in India, who will talk about how she took Charvi's resume zoner and extended it to extract detailed information from resumes and put it into a database using the NLP++ plugin for HPC systems. Take it away, Kruthika.
Hi, everybody. My name is Kruthika, and I have been a part of the HPCC Systems Summer Internship Program of 2023. My project is also Resume Analyzer, which was a continuity of the project explained by Charvi. So to just start off with the introduction, the motive behind this project is just like Charvi said. Amidst increasing digitalization, processes like hiring are also becoming automated because there is a large influx of resumes for various positions. This has led to a need for technologies that can swiftly sort and screen the resumes and find out information. This reduces the manual workload of the organization. So the proposed work utilizes NLP++ to create a custom analyzer, which helps us analyze text in the resume and then perform segmentation and classification of the data. Then the segmented text, generally in the form of a parse tree, will be parsed. This is done by applying a series of NLP++ analyzer passes. to extract information with the help of NLP++ rules and functions. So the general information that can be extracted is like the name, email, qualifications, skills, location, education information like the education institution, grades, the duration which he spent in that education institution, the companies, certifications, etc. So why NLP++? Firstly, because it is the only programming language for natural language processing. I say this because although there are some other languages that may provide support for NLP, NLP++ is specific to the task and works really well with text. It helps us analyze text just the way a human does. It has a lot of features, but these are some that I found were very useful in my project. So firstly, we have the parse tree, which is responsible for converting the resume text into a tree-like structure where each node in the tree represents a token in the text. A token is basically like the smallest unit, which could be a word, a full stop, a question mark, etc. Next, we have the dictionaries, both predefined and custom. One example is a month-days dictionary, which is available, which takes words like NOV and November and refer to them as the same month. And it also gives additional information like it is the 11th month. Apart from this, we have the custom dictionaries, which are built depending on the vocabulary required for the project. Then we have the knowledge base, which can be thought of like the human brain. So it helps us to store the required information. In this case, the past information from the resume is stored on to the KB. Next, we have the rules and the code section. Rules help you to define how to work with the resume content. They work with the parse tree. What you do is you can group nodes together based on a particular rule that you wish to match the nodes. So matched concept is the content is put under a concept which is user defined, and that is per his requirement as to how he wishes to process the text. Then we have the code area, which helps us to work with the KB, also create the KB, and it also helps us to work with the content in the parse tree. Now dictionaries help to assign textual meaning to the text, but code can help us to assign contextual meaning so that you can look beyond and ahead certain nodes and understand what is the context of the text. So the first part was converting text in a PDF or docs format to text, which was similar to what Charvi did. But one problem that I found was doc to text or PDF to text Python libraries didn't perform as required. So as you can see here, we have a resume which is in a 2-column format. And this is a very popular format. But what was happening with these libraries was that the text in both the columns was getting merged together. So instead of that, I found another library, which is PyMicroPDF, which helped me to analyze text column-wise. And you can see the text has been gathered correctly. This is the output. Then next is the collection of words, which comes as part of the vocabulary building for the analyzer. So here are some of the dictionaries that I have created. The first one is a headers dictionary, which is the common headers which are used in a resume. I have stored all the possible synonyms as well, but just having this word in the text does not indicate that it is a header. You may have a header like my experience or the projects that I worked on. Then by looking at capitalization of the text and some other rules, you can find out that one of these words, they say projects in the sentence, is a header. That's when we can isolate that particular textual part as a header. Then the next is the dictionary for all the domain names and hyperlinks, and this is to find links in the document. Here I have another dictionary for the words that come in between sentences. So this is for isolating prose. Prose is like, let's say you have a sentence spanning for more than one line. Then by looking at the first word of the line, you can tell whether this line belongs to the series of the previous lines or not. So let's say you have 2 lines like I have worked and the next line is in Google. So by looking at the first word in, you know it's a between word, and then you also know that it's not capitalized. So we can say that it belongs to the previous series of lines. And that is what prose is. Then the final dictionary that I put here is for referring to education institutions. We know that a particular line which contains these words is talking something about education, and then we can write further rules to extract other information like probably the institution name or other details. Then we have the formatting. This is the first part of the analyzer. General textual analysis of documents requires noting the format, which is used for the organization of the text. And this is what we call as zoning. So that's where you break up text into different sections. And this is what has been explained by Charvi. I enhanced this by expanding the vocabulary of headers. Next, we have the isolation of the smaller components that are found in the resume, like links. So here we have we first find the domain token like com, org or biz, which is for biz, etc. And we see that if this word is preceded by a period, then we know that this text is talking about links. So let's say .com, .org, that section is talking about a link. Then we can write further rules to isolate the link, and you can see the output has been displayed here. Next, we have the phone numbers. There are many different formats for phone numbers of length 10, 11, 12, and may contain brackets or may contain a plus sign. So rules have been written to isolate all the different types. That also has the output has been put up here. Then we have the email, which is like just a specialization of links. Then languages and programming languages for which dictionaries have been created. And these dictionaries, along with the context of the text, has been used to find out the details of the languages and programming languages. So what this means is that, let's say we have a text saying, Dr. Clark worked in Java, and he specializes in snakes like Python. The general keyword search may indicate that Clark knows Java and Python as programming languages, but that sentence meaning meant that he lives on Java island and specializes in learning about reptiles like Python. But NLP++ instead helps you to write rules that not only look at the word, but also the context of text and decide whether Java was a language or an island. Then we have finding more components in the resume, like the dates and date types. There are so many ways people write dates. So there's one like day, month, year, year, month, day. Also say 16 July 2013, July 12, 2023. And there also ranges like November 2023 to December 2024, from July 23 till present or current, etc. And for all of these types, rules have been written to isolate all of them. And then also information regarding the day, month, and year has been extracted. We use this information to find out the range between the two dates in case he has mentioned a date range. Then the information is found out in the format of the number of days, months, and years. Then we have education institution names, the education information, bullets, brackets that can span for more than one line. Not only brackets, you may have quotation marks, you may have curly braces, you may have parentheses which span for more than one line. So all the information that comes under these two under the opening and closing bracket is grouped together. Then we have the pros, skills, and hobbies. Next is the construction of the knowledge base. So the knowledge base helps to paint a comprehensive picture of the candidate with all of his information stored in a hierarchical fashion. So on my right side, you can see that the knowledge base has been mentioned with the different zones available and all the information that has been gathered by the analyzer under these zones. So to build a knowledge base, the power of parse tree has been used. The required information is made as an attribute of a main node of the tree. Then this node is passed with the help of rules, and accordingly different concepts are created that are reflected on the knowledge base. So here you have concept like section, name, email under the header zone 1. Those are concepts, and the corresponding information has been put there. For this, NLP++ rules and functions have been used. Also, the inbuilt or predefined KB functions, which are functions which deal with the knowledge base, they have also been used for working with the knowledge base. This is the last part of the project, so wherein we convert the knowledge base to a record structure. So to accomplish this, the created knowledge base has been converted to an XML file. This is done because ECL works really well with XML. The indentations that you see in the XML serve as the nesting in the record. And therefore, all the information that the candidate has been put up here in the XML file has been converted to a record. Once this has been accomplished, the details of the candidate can be queried accordingly from this record as per the company's requirements. So let's say the company's requirement is that they want all the candidates who have the telephone area as 212. So once you give a query for that, that information is queried from the record based on the query written. And by this, the company can select a candidate of their choice effectively. So this is the conclusion of the project. The information of the individual can be queried from the ECL record according to the requirement of the company. Thank you.
Thank you very much, Kruthika. That was amazing work. Congratulations. Next, we have Pedro Rodrigues from São Paulo University in Brazil, who has created a digital human reader for tweets in Portuguese and extracts and graphs the emotions of fans as they watch soccer games. You can only imagine Brazilians are very passionate about their soccer games. Take it away, Pedro.
Thanks, David. Hello, everyone. My name is Pedro, and I'm from Brazil. And today I'm going to present my project about emotions detection and social media posts in Brazilian Portuguese. First, I'm going to talk a little bit about the overview of my project. The main objective of this project was to identify the emotion contained in posts written in Brazilian Portuguese on the social network Twitter. You know that soccer stimulates intense emotions in fans who express themselves in many ways, including Twitter. So because of this, we decided to use tweets related to a Brazilian soccer team. To do this, the NLP++ language was used. For those who don't know, this language uses syntactic matching of patterns in the text to perform a task. With a small amount of text, it's possible to encode your linguistic and word knowledge to perform a task. And if a problem appears, it's possible to explain why the problem happened and to correct it, since all the code is visible as a glass box. The supercomputing platform HPCC Systems was also used, because the number of tweets generated during a soccer match is very high. So HPCC Systems is a platform developed for big data and can process a large amount of data. The project has followed these 5 steps, and I will talk more about each one of them in the following slides. The first task was to capture tweets related to the team. The tweets were collected every 50 minutes from the beginning to the end of the soccer match. So for each match, 9 extractions were made. The second step was to analyze in detail each tweet. In this stage, it was important to create a taxonomy for emotions because it better delimits the scope of the classifier. There are already some famous taxonomies, but since the context of the project is very specific, we decided to create a specific taxonomy for football fans. The emotions that were most frequently present in this tweets were included in this taxonomy, such as support, anger, happiness, and fun. The next step was to think about how a human performs the task of classifying each text into these emotions. Now I'm going to give just some examples of the analyzer. A very common linguistic construction in these tweets is the repetition of letter in words. So it was necessary to create a way for the code to identify these words without having to list all the possible combinations. For this, a function was created that returns if the word is the same as the benchmark or not. And this function was used to identify if the word is really the word go or not. If it's true, the tweet was classified as happiness. The identification of emotions was performed via a knowledge base. Each time a linguistic construction that characterizes an emotion appears in the text, a point is added to this emotion. To refer to the team, fans can use many forms and all of them should be understood by the analyzer. For example, a possessive pronoun such as my or our, followed by many possible nouns. The logic consisted of classifying as support when the expression let's go or its variations is followed by a mention of the team. A similar logic was used with insults. The tweet is classified as anger when the insult is followed by a mention of the team. And the comma between the insult and the team name is optional, as shown in this code. As I have already said, it's important to use a tool for processing massive volumes of data, for example, HPCC systems. The first step was to call the NLP++ analyzer to process all the tweets in the dataset. At this point, a nested dataset was created as shown in this first table. But for each tweet, there should be only one predominant emotion. So within each row, only the emotion with the highest count was kept. Finally, a dataset was created where the 4 emotions are listed in the columns and the 9 time periods are listed in the rows. And the dataset is populated with the total number of tweets that were classified in each emotions, as shown in this second table. The output of the project was a graphic with the percentage of each emotion at each moment of the soccer match. To generate this graphic, a data visualization package from HPCC Systems was used. One of the goals of the logic of the graphical analysis was to understand if the results shown in this graphic are related to the event that occurred during the soccer match, such as goals, penalties, and cards. The first graphic is from a match on October 3rd, and the red line shows the moment when the team received a red card. And you can see that after this moment, the emotion anger has increased. And the second graphic is from a match on January 19th, and the green line marks the moment when the team scored a goal. You can see that the emotion support has increased after that. So this is the end of my presentation. I hope you have enjoyed. And if you have any questions, feel free to contact me or to send me a message in the chat.
Thank you very much, Pedro. That was great. I do have a question. What was the accuracy of your sentiment analysis?
80%.
Okay, so 80 or 90%. I remember you
Yeah.
showing some of them showing about 94%. The anger
Yeah.
was more around 80%. And
Yeah.
that was with not a whole lot of work on the analyzer, correct?
Yeah.
So you can imagine that you can really bump up the accuracy with even more work on it, correct?
Yes.
Okay, well, great work. I appreciate it. Thank you so much. Next, we have Dheemonth Kodali, who is a student also from RVSE University in India, who will talk about his human digital reader that reads tweets in English about Indian cricket games and extracts the emotional response of fans about specific cricket players and teams. Take away, Dheemonth.
Hello everyone. So coming to my topic, sentiment analysis in English. This is my internship project for the year 2023 and HPCC Systems. So let's get started. So for the quick overview of what I'm going to speak today, I'll be going on through the journey with me and NLP++ and the different sentiments that I was able to do and the benefits that NLP++ provided me during my internship project. So coming to the journey between me and NLP++. If you are an NLP enthusiastic, just like me, then NLP++ is one of the best programming language you can use for NLP. And it's so addictive, so easy to use and easy to understand as well. And it's effective. Its simplicity is going to pave way for the future for the human-based approaches. And obviously, when you will be having so much fun once you start coding with NLP++. And it's always interesting too. So with NLP, what did I do with NLP++ in my hand for this internship project? You can start from generic examples to the real world examples that we are going to do. As specific sentiments only specific to the cricket tweets that are done in India through Indian Premier League. And the first ever human-based approach, wherein we are performing sentiment analysis with just our human things rather than our computer things through NLP++. So coming to the topic, cricket sentiments. The expression of human emotions on cricket tweets is a reflection of the passion that the people have for the game. It also shows how cricket can bring people together and share and create the shared experiences. One can either share it as a positively, negatively, and some may be sarcastic too. But our analyzers are capable of identifying them based on our human things, whether they're very positive about the tweet that they are sent, or they're negative, or they're being sarcastic through a multilinguistic approach. Wherein, for example, if there are some Indians who actually tweet them in Hindi, and our analyzer can identify them in English whether they are sarcastic or not. Then, one of the best advantages that I add while using NLP++ is the dictionaries. And the best, and as you can see on your left, is the cricket players dictionary that I have invented, wherein a Indian person can either tweet in any language they need. The complete player name, or just half of his name. Maybe you may do a nickname, a pen name. It may be anything. But our dictionaries that we have created here will identify them properly, whether they use their names completely or just say a bit less compared to or a nickname with them. Our analyzers will identify them, the names, the sport they're playing, and the country from where they're coming from. And the best part with the NLP+ dictionaries from this year is the use of emojis. When was the last time when we had attributes for emojis that are only specific to cricket? No, right? And we are here with the different attribute values for each emojis. They may be positive, negative, neutral. Each emoji and their attribute values are specific completely to the Indian cricket matches. Say, for example, a fire emoji, which specifies its emotion, a positive value of 5, negative value of 2, and can be a neutral also. where these neutral values help us by identifying the sarcastic meanings. So the next part would be the KBB building, where we are building the knowledge base after finding a specific sentiments to the tweets. The sentiments may be many kinds. Few of the sentiments that we have performed here are the player sentiment, cricket freaks. I mean, any enthusiastic cricket follower knows each player and each game what they're playing, whether they're playing well or whether they're playing poor, and the support that each user does, like whether they're supporting the team or not. Say, for example, as you can see in the snapshot, for the player sentiment, we display the player name and the emoji they are displaying along with that, and the sentiment type too. Along with that, say for cricket freaks, they say a player is smashing runs exclusively in the cricket match. Then we say they're very happy with that and they're positive. And even there are emojis where we either thumbs up or thumbs down for a specific team. If it's a thumbs up, we say that they are supporting for the team very well. If it's a down, we say that they are not supporting and they are not happy with the team's performance. And that may be sarcastic too. And there are some examples like where they say a player has performed very well and they they continue with the emojis with the laughing symbols. And at the end, there'll be a slight wink or a slight sad symbol with stating that they are sarcastic. Our analyzers are capable of identifying whether those tweets are sarcastic, positive, or neutral. So, with NLP plus in our hand, what are the possibilities for the next future? Start from computerized probabilistic nature to human emotion based. We always start sentiment analysis with just statistics. Like we usually have, these are the values for the words, the keywords that we are finding, but not anymore. With NLP it's completely human based, and how a human thinks, how a human can perceive the tweets, how a human understands the tweets whenever he reads them is possible through NLP. And just imagine with HPCC systems in our hand, with this huge corpus of data, we can analyze them in one go. Then finally, leave statistics and start with the analyzers. NLP helps us to start with completely analysis with different analyzers working under them. And statistics has no place into the human-based approaches. Thank you, everyone. That's the end of my presentation. If you have any doubts, just chat me in with my mail ID. Thank you.
Thank you so much, Dheemonth. That was really interesting. It was really interesting to see how both you and Pedro dealt with sentiment analysis, the things that were very different and very specific to your task. And that was, I think, one of the pluses of using NLP++ is you can design it specifically for that one task. So congratulations again.
Thank you.
Next, we have Shyamaa Karthik, and he is a high school student here in Florida who will talk about his human digital reader for creating a Tamil dictionary from sources online, including Wiktionary. Shyamaa is making history in creating the very first NLP dictionary available in NLP++ for Tamil. Take it away.
Thank you. So my project is processing the Tamil Wiktionary pages into an NLP++ dictionary. So a little bit of background or of project context. Tamil is a language my family speaks, specifically my parents who came from Tamil Nadu, India. It is the 5th largest language in the most populated country in the world, which makes it usable by a large group of people. The more languages that are part of NLP++, the more effective natural language processing becomes because it gets more widespread and prevalent. So the more people and across the world that we have that can use it in their language, the more widespread our database grows and the more effective it becomes. So a little bit of background on how the project works, really. So what it does is if you input a bunch of Tamil text, for example, as you see in the text.txt input, so that roughly translates to the van drives up the hill. So when you run it, you would have a dictionary tokenizer, as you can see in the analyzer sequence. What you would do is you would load up the top full dictionary in your KB section, which stands for knowledge base. And you would simply hit the run button next to your text input. And what you would get is a tree or a tree, NLP++ tree that looks sort of like this. And what you have is for each word, it would come with its own tag of part of speech. So you can see the first word is a noun, the second word is also a noun, the third word is a verb. So you see noun one, verb one next to each of the words in the final tree. So that's kind of like the output of my code and how it works. And so now what that allows people to do who speak Tamil across the world is now they can process their own text and have it tagged for part of speech, which is extremely useful for them. So a couple of modifications to the NLP++ engine. So the NLP++ engine previously was reading a Tamil diacritic as punctuation, and it was splitting singular words into multiple words. So that one word you see on my bullet point, that's one Tamil word, but in the screenshot below, you can see how NLP++ engine, it was parsing it as 4 separate things. It was parsing it as one alphanumeric, which is like one word, punctuation, then another word, another punctuation. So it was reading it really as 4 nodes or 4 separate things. And instead of that, we needed to modify it to read it as one word. And how we did that was we actually went a little bit extra and we looked into the hexadecimal values for that one, how it was reading as to control. It's actually called in Tamil, it's called a pulley. It's a diacritic, kind of like how an accent is in Spanish, like how you put a little accent over certain letters. That's kind of how this pulley is for Tamil. So what we had to do is we had to go in and read into the hexadecimal values for it and add it to the NLP++ engine so that it would read it as singular words. So my project, it was based off of the English Wiktionary parser model. So the English Wiktionary parser was a project I used to model my own parser after. And it wasn't, even though it wasn't the exact same project because I wasn't able to use the Tamil Wiktionary for my source, it just goes to show how much an NLP++ can be built on through multiple projects. In a similar fashion, my parser can be built on through future projects by growing to include more and more sources. So that'll grow the Tamil dictionary's coverage because it's not exactly the most thorough dictionary, even though it is the first. So it just goes to show like how much NLP++ like can be built on. Like even though projects aren't the exact same, there's enough of a link between each of them because it's just all natural language processing that you can build on and use previous projects as references. So the importance is that this is the first Tamil dictionary with parts of speech for NLP++, which is the best medium for natural language processing. So what this does is it allows people from Tamil, Sri Lanka, and Singapore to use NLP++ for natural language processing. And even though the dictionary isn't the most thorough or complete, it still serves as a baseline for future projects. So this is like a starting point for any future interns or people working at HPC Systems to look into and build and expand with further research. And another interesting point is because I couldn't use the Wikitext pages, we could look into expanding their source too, because their source wasn't as thorough or complete as it needed to be. So it could be a really good partnership with them and look into growing that source as well. And personally, this project was a lot of fun to me because I got to work with my dad a lot on the linguistic portion. Because even though I can speak Tamil, I can't really read it. And I needed his help with that part. And that really goes to show that NLP++ allows us to make connections in a growing community. And just like, because natural language processing is the big part of it. And it's like linguistic is the most important part of this, I feel. So what that does is really like makes a tight-knit community, just like a growing communication-wise. Thank you.
Thank you so much, Shyam. It's really historic to have a first dictionary in Tamil. And if I understand, there are 89 million speakers of Tamil. Is that correct?
Mm-hmm.
So this is really opening that up, and great to see you involving not only you, but your family and really making this a bigger than just the simple programming project. Congratulations.
Thank you.
As you can see, the NLP++ plugin for HPC Systems has opened the door to a new and exciting way to read and process text that was virtually impossible before this technology. Unlike statistical methods, the digital human readers are 100% visible and traceable when used in critical, real-world systems. And after listening to this group of brilliant students from around the world, I have no doubt that the future of computer science is in good hands. So I thought before we wrap up, we'd talk about how NLP++ is different. We always are programming by thinking how computers do things, and NLP++ forces us how to do a thing, to think about how we humans do something, which is very different. So, Kruthika, how did you find it? What did you find when you were using NLP++ and having to think like humans?
So, like you said, it was very different from traditional programming languages. There is literally, you have to think like human, and that is what the rule is. So when I was working on a particular part wherein I wanted to find an educational institution name, so as human beings, we would not know all the names of all the institutions in the country, but we do know because of words like college and then capitalization in words that we use when we try to find out an education name. And that is the kind of principle that I applied specific to this example. But generally, yes, it always is good when you think like a human and you look at text just how you would, and then you would write specific rules in that way so that you can get information out from text.
Very good. Yeah. And it's, I think it's fascinating. You can encode it. NLP++ allows you, once you do discover it, it allows you to do that. So Pedro, when you were looking at the tweets in Brazil, you had to kind of think out how do people understand those, right? I mean, it was not just an algorithmic problem. It was a problem of trying to think of how people are thinking. Tell us about that.
Yeah. Before that, I have never worked with processing natural language, and my first experience was with NLP++, and it was very cool to think how a human performs this task, to classify a task into emotions. And yeah, it was a very good work.
Right. And you also did it in Portuguese. And it was interesting that these things are very specific. I think when you started out, we were talking about very generic emotions. I'm sure Dheemonth had that same thing. But we quickly found, I think, you had to be very specific, right? You had to write this for this, not only specific for soccer games, but to a certain team, correct?
Yes. If, for example, you have to use this analyzer for another team, it's important to make changes in this analyzer to make this analyzer good for another analysis and another team or another context also.
Right, exactly. And that's really important. I think we always think of NLP as just go grab a package, and there's just no way I think you can do these kinds of things. Dheemonth, now you worked on the cricket games, and I noticed in the beginning you were kind of not thinking as a human, but all of a sudden, I remember almost the day when all of a sudden it, like a light bulb came up, and now I get it. Tell us about that discovery.
Yeah, David. Like, I am more often interested in machine language and NLP, but both were completely statistical based. Now, directly facing a human based approach was very difficult for me. It was out of my comfort zone, and NLP plus helped me a lot. I mean, for the first few weeks, it was like, oh, come on, we have to think. I need an algorithm, how to work on that. But now, no need to do any algorithm. Just be like, understand the tweets. Oh, this is what the tweets mean. Let me encode it. Like, let me make a rule on that and let me solve it. Yeah, this is how a human works on that. It was quite challenging, but it was very fun at the end. I'm like, I used to play it a lot too.
Very good. Yeah, it is addictive. I did write an article on the website about how this is addictive. Thank you so much. Shyamaa, now you were talking about, I think it's very interesting how now you are seeing this as the beginning of NLP in a language that has 89 million speakers. Right now, it would seem hard to do that without a dictionary. So tell us about that. I mean, you really made a kind of a profound statement at the end. Tell us about how you really think this can be the start of doing NLP in Tamil.
So this, like, really, to start with any sort of text processing with natural language processing, you really need part of speech, right? It's like, that's like the stepping stone to really everything. And what this does is sort of like, it gives like the start to the key to just allowing NLP++ to take off in really in Tamil, in India, Sri Lanka, Singapore, and a bunch of countries where a lot of people live, like seriously, like a lot. Like you said, I think 89 million people. like that's just now everyone who can just unlock the key of NLP++. And now what they can do is they can process their own text and basically anything they want, really. And what they can do now is, since they're native speakers of that language, they also have access to larger dictionaries and resources. So what they can do is add on to it with any words that they see that are missing or lacking. Because now they have sort of like a building block in what I wrote, and they can add on to it with their own code.
Right. It is an open source project. In fact, if you download the NLP++ plugin now, you can download the Tamil dictionary in its form right now. And as you know, we've got a lot of work to do on it, but it's a great start. Congratulations. Now, Charvi, it was interesting when I first worked with you, is when we were talking I was talking to your managers. They were thinking in old school stuff, keywords and that kind of thing. And we really I really literally had to have a session and teach them what this was all about. It was very different. Tell us about that, Charvi.
Yeah, so again, like when it comes to everyone, when they ask like how are you programming, so again, when it comes to NLP++, you really don't have to think of yourself as a programmer. You really have to make yourself put yourself in the position of a human. So what NLP++ does very well is it emulates the way humans process and how they understand the text, so as opposed to simply programmers. So it is putting yourself in perspective, thinking about humans thinking like humans, and like it's just a really powerful language to work with. So it gives us the syntactic tree and everything. And I think just like, again, like just keywords and specific textbook answers is not what we're looking for. We're trying to really explore the text, trying to explore natural language and see how much information, whatever, that we can extract from it as much as we can.
Yeah, thank you very much, Charvi. It is. I mean, I really did was amazed to see the change where people, even your managers at the time, said, "Oh, wow, we can really do this." So congratulations to everybody. I think the projects were amazing. You guys picked up an entirely new way of programming, which is not easy. I will tell you, I was shocked that everybody got it and enjoyed themselves. So thank you once again for some great projects with NLP. And I see great, bright futures for all of you. Thank you so much.